So our first problem, a 10-sided die is rolled. So we have a dice with 10 sides. So event A is an even number. If you are rolling a 10-sided dice, what would be the even numbers that you could roll?
2, 4, 6, 8, 0.
And we would have 10, right? Because a 6-sided die starts at 1 and ends at 6.
A D10 has a 0, not a 10.
Oh,
That's okay.
sorry. Number less than 6. So 1, 2, 3, 4, or 5. And number greater than 8. So what would my options be? 9 and 10. All right. So those are the different options for what I can roll. So first question, what is the probability of B? So how many numbers are in set B? 5. If we have a 10-sided dice, how many options are there?
10.
So 5 out of the 10 or
0.5.
0.5. The probability of C. So how many options are in C?
2 out of 10.
Out of 10 is 0.2. C, the probability of both A and B. So looking at my numbers, how many of them are listed in A and in B?
2.
The 2 is in both, and the 4 is in both. So I have 2 numbers that show up in both out of
10.
the 10 numbers on my dice. So 0.2. A or C. So we still just have 10 sides. I'm wanting anything that shows up in one or the other. So a couple different ways of doing it. You could do the whole formula, the first one plus the second one minus the overlap. You could count, you could make a list of the numbers we have. Like between the two, we have a 1, we have a 2, we have a 3, we have a 4, we have a 5, we have...
A and C? There's no
Oh, sorry, I was doing A and B. Between A and C, so we have 2, 4, 6, 8, and 10 in set A. In set C, we also have a 9. Would I need to list the 10 again? No. So how many numbers? 6 out of the 10 options, so 0.6. All right, are these going okay so far? All right, next one, C given A. When you have a given, that's something we already know. So it is given A. How many numbers are in A?
5.
Okay, so I already know my number is either 2, 4, 6, 8, or 10. How many of those are in set C?
1.
1. So 1/5 or 0.2. B given C. So I know that I'm in set C. How many numbers are in set C?
2.
How many of those 2 numbers are in set B?
0.
So that would be 0. Are A and B mutually exclusive? What does mutually exclusive mean?
No overlap.
No overlap. Do they have anything in common?
Yes.
Yes. So they are not mutually exclusive. Okay. The definition of independent says that the probability of something happening is the probability of that if the other already occurred. Or it could be the probability of C has to equal the probability of C given A if they're independent. Even if one happened, the other didn't change. We've kind of done these calculations for the second one. What's the probability of being in set C?
0.2.
What's the probability of being in C given that you were already in set A?
0.2.
If those are the same, then that means
Independent.
yes, they are independent.
You only have to do that for one of the sets.
All right. So that kind of refreshed our basic probabilities, ands, ors, conditional, mutually exclusive, independent. Any questions about that? Let's look at a few more. In order to be accepted into a graduate program, applicants must get a qualifying score on the GRE and have an acceptable GPA. From past experience, The admissions counselor knows that the probability of having an acceptable GPA is 0.83. Okay, so probability they have the GPA is 0.83. And that of those with an acceptable GPA, the probability of getting an acceptable score is 0.64. So the probability that they have the score, given that they already met that GPA requirement, because I'm only looking at the students with that GPA, is 0.64. What's the probability to get accepted? We know to get accepted, they have to have probability of the score and the GPA, and tells me multiply. So we're just taking the probability of the GPA times the probability they get their score if they already have the GPA. This, you don't necessarily have to show all this work, but this is kind of my explanation for why it works. So we just do our 0.83 times the 0.64.
Would it be really wrong to use the other formula?
No,
No.
the given one, that's fine.
Okay.
More than one way to do that. Alright. Ready for another one? Okay, in a game, you draw cards from a deck containing 3 black cards and 5 red cards. So I know, in my deck, I have 3 black ones, 5 red ones. To win a turn, you must get 3 black cards in a row. To win the game, you must get 5 red cards in a row. So find the probability of winning another turn. So another turn means you have to get black and black and black, right? What is the probability that my first card is a black?
3 out of 8.
Okay, there are currently 3 blacks out of my 8 cards there. If I take out a black, for my next one, how many black cards are there?
2 out of 8. 7.
2 out of 7. Okay, if I take out that black card, now I have 1 out of 6. And we could multiply that, right? To win the game, what do we have to get?
5 reds.
Okay. What is the probability that my first card is a red?
5 out of 8.
Okay, if we take out a red, what's the probability the next one is red?
7.
I take that one out, what's the probability the next one is red?
36.
I take that one out.
2, 5.
And if you take that one out, the last one is
1, 4.
1 over 4. Is that okay? Not winning anything. How do you not win anything?
If you pull a black and a red, or a red and a black.
Really, anything.
Softball is dismissed. Softball is dismissed.
Good luck, ladies. So, we know we can either get 3 blacks or 5 reds and win. Not winning anything is the opposite, so you basically just have to do 1 minus both of those probabilities. Do you guys get what I mean by that?
So 1 minus A
Also
minus B.
Okay, so if I did like part A, I didn't multiply it all out, but if I had,
Oh, okay.
that would be 0.0179, so I'd have to subtract that one. And then if I do B, we get actually the exact same thing. So we subtract both of those, because those are the 2 ways we win. Not winning would be anything else.
You have a 1% chance of winning this game.
Yeah, it's
It
rigged
seems-
against you.
It seems dumb.
Is that one okay?
Yes.
Let's do just a couple more. We've had a lot of these table type questions. So, let's see, if I tally up real quick. So there's 107 in my guess. 121 there, so my grand total would be 228. Okay, so probability of yes given it's a fifth grader. So all I'm looking for is my fifth grade. Ignore the rest. If you need to, I'll give you a sticky note. Cover up the rest of that table. How many fifth graders are there? Of those, how many said yes? And that would be your answer. The probability of no. How many no's are there? Out of? The probability of eighth and yes. So how many were eighth and yes? 41 out of eighth given yes. So that changed it. Now I know their answer was yes. We already know that. So I am only looking at the yeses. How many yeses are there? Out of those, how many were eighth? And you would divide it and get your answer. Is that okay? Is this helping? Do you want me to do a couple more, or do you want me to quit? A couple more. All right. I have 2 more slides. Look at me. Ready to go. All right, so this one. I am decorating pumpkins for a party. 65% of the pumpkins are carved. So the probability my pumpkin is carved is 65%. And this is how you know it is not really my party, because I despise carving pumpkins. There would be no carved pumpkins. Would you come help my kids carve pumpkins if you enjoy it?
Yes.
I bought pumpkins last night. Somebody has to come help them. Please. I hate it.
If I had spare time,
73% are carved or painted. So the probability of carved or painted is 0.73. 21% are painted. What percentage are both carved and painted?
you can just multiply the carb and the pain together.
Only we know they're independent. Okay, so this looks like a lot. Whenever I have a lot of information, I go to my formula sheet. Okay, I have an and, I have an or, I have individual things. What's the only formula that has both the and the or in it?
General addition.
Okay, the probability of, I think it's E or F on your formula sheet, is probability of E plus probability of F minus probability of E and F. So we plug in what we know. E or F, carved or painted, 0.73. Probability of E, carved, 0.65. Probability of F, painted, 0.21. Minus the probability of both. And then what would you do from here?
Add, subtract, divide.
So we would have 0.73 equals 0.86 minus probability of both. Subtract over my 0.86. So the probability that it is both carved and painted, 0.13. Is that okay? Last one, just seeing, do you know how to use a formula? And this is very similar to what we just did, isn't it? So the probability of C and D. If probability of C is 0.7, probability of D is 0.16, how about C or D is 0.82. So when I give you all those, you're just finding the formula. What formula involves all these things? E or F, in this case C or D. It's probability of the first, it's probability of the second, minus probability of C and D. So Are you guys okay if I don't solve this?
Yeah.
It's just like the last one, but just a matter of using your formula and plugging in things. Alright. Any other questions? So, I will take those packets from yesterday